Hello everyone. Question is a machine learning specialist is given a structured data set on the shopping habits of a company's customer base. The dataset contains thousands of columns of data and hundreds of numerical columns for each customer. The specialist wants to identify whether there are natural groupings for these columns across all customers and visualize the results as quickly as possible. What approach should the specialist take to accomplish these tasks? Option A. Embed the numerical features using the T-distributed stochastic neighbor embedding T-SNE algorithm and create a scatter plot. Option B. Run k-means using the Euclidean distance measure for different values of k and create an elbow plot. Option C. Embed the numerical features using the T-distributed stochastic neighbor embedding T-SNE algorithm and create a line graph. Option D. Run k-means using the Euclidean distance measure for different values of k and create box plots for each numerical column within each cluster. Correct answer is option A. Question is a company wants to predict the sales price of houses based on available historical sales data. The target variable in the company's data set is the sale price. The features include parameters such as the lot size, living area measurements, non-living area measurements, number of bedrooms, number of bathrooms, year built, and postal code. The company wants to use multivariable linear regression to predict house sale prices. Which steps should a machine learning specialist take to remove features that are irrelevant for the analysis and reduce the model's complexity? Option A. Plot a histogram of the features and compute their standard deviation. Remove features with high variance. Option B. Plot a histogram of the features and compute their standard deviation. Remove features with low variance. Option C. Build a heat map showing the correlation of the dataset against itself. Remove features with low manual correlation scores. Option D. Run a correlation check of all features against the target variable. Remove features with low target variable correlation scores. Correct answer is option D. You can download the complete list of recently updated contents from the link provided in the description. If you like this content, please like and subscribe. Question is, a technology startup is using complex deep neural networks and GPU compute to recommend the company's products to its existing customers based upon each customer's habits and interactions. The solution currently pulls each dataset from an Amazon S3 bucket before loading the data into a TensorFlow model pulled from the company's Git repository that runs locally. This job then runs for several hours while continually outputting its progress to the same S3 bucket. The job can be paused, restarted, and continued at any time in the event of a failure, and is run from a central queue. Senior managers are concerned about the complexity of the solution's resource management and the cost involved in repeating the process regularly. They ask for the workload to be automated so it runs once a week, starting Monday and completing by the close of business Friday. Which architecture should be used to scale the solution at the lowest cost? Option A. Implement the solution using AWS Deep Learning containers and run the container as a job using AWS Batch on a GPU-compatible Spot instance. Option B. Implement the solution using a low-cost GPU-compatible Amazon EC2 instance and use the AWS Instance Scheduler to schedule the task. Option C. Implement the solution using AWS Deep Learning containers. Run the workload using AWS Fargate running on Spot instances and then schedule the task using the built-in task scheduler. Option D. Implement the solution using Amazon ECS running on Spot instances and schedule the task using the ECS service scheduler. Correct answer is option A. You can download the complete list of recently updated contents from the link provided in the description. If you like this content, please like and subscribe.